In this last lecture from Chapter 8, we will extend the idea of confidence intervals to a population proportion. The general form for an interval estimate of a proportion is the same as for the mean. In other words, we will take the sample proportion plus or minus a margin of error. Just as we discussed with the sampling distribution from Chapter 7, we can use the normal distribution when n times p is greater than or equal to 5 and n times 1 minus p is greater than or equal to 5, p being the sample proportion or the population. The sampling distribution of the proportion using the normal distribution looks exactly like that for the mean. We place a confidence interval given a significance level alpha, putting alpha over 2 in each of the two tails. Remember the formula for the standard error of the proportion, which was the square root of p times 1 minus p divided by n. Just like with the mean, the formula for the margin of error requires the z value for alpha over 2. In this case, this formula would be taking the sample proportion, p bar, plus or minus that margin of error. Let's look at an example for proportions. We have polls and surveys. And from that survey, we get a sample proportion of 220 out of 500. This sample proportion would equal 0.44. And we want a 95% confidence interval around that sample proportion to predict the population proportion. The z value for 95% is plus or minus 1.96. So calculating the formula, we end up with an interval around the population proportion plus or minus 0.0435. Just as we did with the sample size for confidence intervals of the mean, we can also work in reverse, and given a margin of error, we can calculate a sample size. However, the p-value, the p-bar value, the sample proportion will not be known until after we've selected the sample. So we need to use a planning value for the sample proportion. The planning value can be chosen a number of ways, but typically, if we can't make a best guess, we just use 0.5. So back to our survey example. Suppose we would like a 99% probability that the sample proportion is within a margin of error plus or minus 0.03. What sample size do we need? Working the formula for margin of error in reverse, it shows we would need a sample size of 1,817. That was done using the known population or the sample proportion of 0.44. We've done this calculation using a best planning value of 0.5, we would have come out with a sample size of 1843, not very different.